Rouche's theorem assignment 2. Example, show that all the roots of z to the power 7 minus 5z square plus 12 equal to 0 lie between the circles mod z equal to 1 and mod z equal to 2. So we have given these two circles. Let's draw these. Suppose this is your circle mod z equal to 1. This is your circle C1, right? And this is your circle C2 having the radius 2, and this circle is having the radius 1. So this is the second circle. I have to show that the roots of the given polynomial lie between the circle, that means this annulus, right? Which means I do not want any root inside C1. Alright, so all the roots should lie between this annulus. So for that, what should I consider my fz to be from this given polynomial? First, I consider the circle C1 in which I do not need any root. That means I have to choose my fz to be a constant polynomial, right? So I choose my fz that is equal to 12 and the remaining part is gz. That is z to the power 7 minus 5z square. Choosing fz first is important and the remaining terms are with gz. So on C1, mod z is equal to 1. So before applying the Rouche's theorem, we must check whether mod of gz is less than mod of fz or not. Right? So let's check. Mod of gz is equal to z to the power 7 minus 5z square mod, which can be written as z square plus minus 5z square. This is your a, this is your b, and we know that mod of a plus b is less than equal to mod a plus mod b. So this is mod a plus this is mod b. Because mod z is equal to 1, I am putting the value of mod z equal to 1 over here. What I will get? 1 plus 5, which is equal to 6. And this 6 is strictly less than 12, which is my fz. Right? I can also take the mod over here. So I got mod of gz is strictly less than mod of fz on C1, which is a required condition for the Rouche's theorem. Now since fz and gz are analytic inside and on C1 with mod of gz strictly less than mod of fz on C1, so by Rouche's theorem, fz plus gz, that means sum of these two functions, has the same number of zeros as fz inside C1, which means number of zeros having fz is equal to the number of zeros of fz plus gz. But fz is constant 12, so it has no zero inside C1, right? If fz is equal to 12z, suppose it is 12z, then we say that it has 1 zero inside C1. If 12z square, then that means it has 2 zeros inside C1. But I am having the only the constant polynomial, so it has no zero inside C1. So therefore fz plus gz, that is equal to, which is your given polynomial, it has also no zero inside C1. Rouche's theorem states that both the functions fz and fz plus gz, they both are having the same number of zeros. Now if fz has no zero, that means fz plus gz is also having no zero inside C1. Now let's check on C1. So mod of fz plus gz is equal to we take the mod of fz plus gz, we have to check inside C1 there is no 0. Let's check, is there any 0 on C1? So for that I'm checking this mod. This mod should comes out to be 0 if it has 0 on C1. This is equal to mod of z the power 7 minus 5z square plus 12, right? Whenever you check this mod, you have to apply the form greater than equal to, right? So this mod is greater than equal to mod A minus mod B. So this further mod greater than equal to, I'm writing like this, 12 minus mod z the power 7 minus 5 mod z square. And mod z is equal to 1, which means this is equal to 12 minus 1 minus 5, which is equal to 6. So mod of fz plus gz is greater than equal to 6 on C1. So for all the values of z, this mod comes out to be either greater than 6 or equal to 6. That means this fz plus gz has no 0 on C1, right? So on C1 also it is having no 0. There is no root. Now we consider the first circle is over now. Now we consider the second one, that is C2, which is mod z is equal to 2. Now here also we have to apply the Rouche's theorem to get the roots. Now because the example says that I have to show that all the roots of the given equation, given polynomial lie between the circles. All the root means all the 7 roots, right? So check your given polynomial. What is the power? 7. That means how many roots it can have? 7 roots. So I must show that all the roots of this lie between the circles mod z equal to 1 and mod z is equal to 2. That means if I consider the bigger circle, I have to show that roots lie inside this bigger circle mod z is equal to 2. So for that I have to choose my fz to be, yes, because I need all the 7 roots, so I have to choose fz to be equal to z the power 7. Very good. So now fz is equal to z the power 7 and the remaining terms are gz, that is minus 5z square plus 12. So on C2 mod z is equal to 2. We have, now again we have to check that mod of gz should be less than, strictly less than mod of fz before applying the Rouche's theorem. So let's check mod of gz here. This is mod of minus 5z square plus 12, which is less than equal to 5 mod of z square plus 12, which is equal to, because mod z is equal to 2, so this will be 20 plus 12, which is 32. Now this number should be less than mod of fz. What is your fz? Z the power 7. And what is your z here? Z is 2. So 2 the power 7. It should be less than 2 the power 7. Is it? Yes. 32 is strictly less than 2 the power 7, which is your mod fz. So we get that mod of gz is strictly less than mod of fz on C2 also. Now since fz and gz being a polynomial, these are analytic inside and on C2 with mod of gz strictly less than mod of fz on C2. So by Rouche's theorem, fz plus gz has the same number of zeros as fz inside C2. But all the 7 zeros of fz, that is equal to z the power 7, lie inside C2, right? So fz plus gz also has all the 7 zeros inside C2, right? Since fz plus gz has no 0 inside and on the circle C1, but all the 7 zeros are inside the circle C2, which means all the 7 zeros lie between C1 and C2. See, this is your inner circle C1, which is having the radius 1, and the outer circle C2, which is having the radius 2. So all the roots are lying between this annulus which is your green colored portion, right? No root of fz plus gz lie inside this C1. And all the roots of fz and gz lies in C2. But inside C2 but outer part of C1. That is only in the green colored region. That is between the circles C1 and C2. So hence the 7 roots of the equation lie between the circle mod z equal to 1 and mod z equal to 2. Alright, just go through this example. We will be doing some other example in the next video. Thank you. Have a good day.